Hi everybody, Patrick here from EngineeringShop.com, ElectronicLessons.com, and now PaintballProps.com. This is video 2 of project number 5 on our multi-project electronics learning board. It's up for pre-order right now at EngineeringShop.com and ElectronicLessons.com. Since this is the second video, this portion of the circuit is talked about in depth in our last video, in video number 1 of 2, so please watch that video or else you're not going to get all of the context. Now, again, all of these blocks, like our LDR circuit, light dependent resistor circuit, voltage divider, our variable resistor voltage divider, our comparator op-amp circuit, our power supply circuit, those are all linked in the tutorials below. We talk about each block in our electronics learning board in the matter of a tutorial, in depth. So, if you're really interested in getting a good grasp on basic electronics, watch the tutorials below. Anyhow, for this video, this is just video number 2 of 2, we've added a laser. So, let's pretend that the laser is not there for a second. We've got our LDR circuit. When there's low light and darkness, there's a higher resistance on our LDR, which means we'll have a higher voltage on our sense line. When there's a lot of light touching our LDR, there will be a lower resistance on our LDR, which means we'll have a lower voltage on our sense line. So we've got our sense line connected to the positive input of our comparator, and we've got a calibrated 2.5 volts. I haven't actually labeled that, sorry, we can watch the last video, from our variable resistor. So we've tuned our variable resistor to output 2.5 volts on the wiper by turning the potentiometer, variable resistor. We place that on our negative input of our comparator label, CMP1 negative. CMP1 plus is connected to our sense line. Anyhow, so when we have a laser pointed at our LDR, whether or not the room is dark or light, there's going to be a lot of light because the laser is a concentrated light on our LDR. So our laser has a red wire and a black wire. Black wire will be connected to our ground line, and there's a common ground line on the electronics learning board, and the VCC will be connected to the positive line, the red wire, on the laser. So we'll just connect that to a 5 volt block. Anyhow, then what you do is you point that at the LDR, and then regardless of whether or not the room is lit up or whether the room is darkness, we're going to see 1 k or less of resistance on our LDR because so much light is hitting it, which means we're going to have a really low voltage here. If we have lower voltage at the positive input of our comparator than we do at the negative, which is 2.5 volts, our output will be low. We've got our output connected to our LED. So, the experiment here, point the LDR, or point the laser at the LDR. Turn out the lights. Make sure it's really dark. But all you should be able to see is your laser pinpointing on your LDR circuit. Now, once you break that beam, then the LDR will see nothing but darkness, correct? Yeah? So then we'll see a higher resistance on our LDR, which means that we'll have a higher voltage on our sense line, and that's connected to the positive. So when there's a higher voltage on the positive than the negative, say we have 4.54 volts on our positive and a calibrated 2.5 volts on our negative, higher voltage on positive than the negative, our output will be high, 5 volts, VCC, and our LED will light up. Now again, this might be confusing if you didn't watch video 1 of 2 for Project 5, and as well, all of the tutorials are below for all of these different blocks. These projects are based on are made for people who have already watched the tutorials, understand these blocks. So hopefully you understand this. If you don't, watch the tutorials, watch project number 5, video 1 of 2. I digress. Let's go hook it up on our learning board. Now, because this is a continuation video, these were our hookups from last time. We've got our LDR circuit connected from our sense line to our CMP1 plus line, our comparator 1 positive input. We've got our calibrated 2.5 volts from our VAR1 variable resistor connected from the VAR1 port to the CMP1 negative line. So our negative comparator input. Our CMP1 comparator 1 out line is connected to our LED, our LED indicator, which is right here. Our LDR is right here. So now what we want to do is we want to take our laser peripheral and we want to connect it to the board. Now I realize the focus may not be great. If you purchase this board, you will get a manual that includes all the links to all of the tutorials and all of the project videos. Your laser peripheral will look something like this. There is a red wire and a black wire connected to pin headers. So you take my red wire and place it in one of the VCC pins, labeled 5 volts in the upper right here. I'm going to take my negative wire, my black wire, place it in one of the common pins on the bottom here, labeled common. All of the bottom rail is ground. So as soon as I plug in my board, what I should see is my laser emitting light. Let's see if I can flash it into the camera. And you see it. So our laser is flashing light. So now what I'm going to do is enough light is always hitting the LDR that the LED is always off. So what I'm going to do is I'm going to turn off all the lights. And I'm going to come back to this. My LED is on. But what if I flash my laser at it? Now I'm going to put my hand in the way of the laser. And I've got a laser detector circuit. Now I'm going to show you a really, really neat way of doing a laser detector circuit. As you can see, I'm just pointing the LDR, pointing the laser at it, and the LED turns on. So it might be a little bit difficult to see here because the laser itself is pretty bright. That's the LED. I bring my laser on the LDR, and there you go. So I'm going to turn the lights back on. And again, we'll discuss this. Remember, the LDR circuit, when there's light touching the LDR, there is a low resistance on it, which means there's a low voltage on the sense line, and that is connected to the positive input of our comparator. We've got 2.5 volts from our variable resistor, our VAR1, our tunable variable resistor output, connected to the negative input of the comparator. So by default, there is in the light, there is more voltage on the negative input than the positive input. So our output is low, 0 volts. So our LED is not lit up because our output is connected to the LED. Now, if we have pitch darkness in the room, by default, there is a higher resistance, a much higher resistance on the LDR, meaning there's a higher voltage on the sense line, which is connected to the positive input of our comparator. That voltage will exceed the 2.5 volts on the negative input of the comparator, which means the output will be high, 5 volts, which will light up our LED. See, I'm covering it up with my hands. So if I have darkness, and again, there's too much light in the room right now, it makes no difference. If I have darkness, like by default in the room, but I've got a laser pointer at the LDR, as soon as I block that light, the LDR will see nothing but darkness, and the LED will light up. Hopefully that makes sense. Watch the other tutorials. Watch the project number 5, video 1 of 2, and this will make a heck of a lot more sense. This is kind of like a bonus video. I wouldn't have really made this video, but I thought it might be fun for you guys to watch it. Actually, the next video is a very, very neat, highly sensitive laser circuit, and we're going to turn on and off some AC devices with it. I realize it's kind of dark in here now. I apologize for that. This has been more of a bonus video, so thanks for watching. Hope you like it. Check us out at engineeringshock.com, electroniclessons.com, and paintballprops.com. Take care, guys.